good evening, and welcome. Tonight we are going to be looking at the night sky in July. First, we're going to look at the northern hemisphere stars, then the southern hemisphere stars. Then we'll look at one of the more prominent constellations at this time of year. And then we'll learn a little bit more about our solar system. So let's just dive right in, starting with the northern hemisphere stars. During July, the star clouds of the Milky Way become very prominent, especially toward the south around Sagittarius and Scorpius. To the north of Scorpius, you will find the large constellation of Ophiuchus. I forgot how to pronounce that, but anyway. The serpent holder. The serpent coiled around him is represented by a separate constellation, Serpens. Above the serpent's head is the distinctive shape of Corona Borealis. Although most of the stars in this small constellation are fourth magnitude, the little arc they make is easy to spot. Let's see if we can find those. Let's see. There's this guy. My problem is that I always thought it was Ophiuchus, and then I found out it wasn't that, but I forget what it actually is. Ophiuchus. I don't remember. Anyway, because there's Scorpius and Sagittarius. They're very easy to spot. Ophiuchus. We've got Serpens over here. What else did I mention? Corona Borealis. I think that's all I talked about. Yeah, let's read a little bit more about Corona Borealis. This attractive semicircle of 7 stars depicts the crown of Ariadne, a mythical princess. Upon marrying the god Dionysus, her crown was thrown into the sky, where the jewels became stars. The brightest of them is called Gemma, the Latin for jewel. I didn't know that. Let's read about Serpens. This one's really interesting. Serpens is the only divided constellation. Its head, Serpens caput, is on the side of Ophiuchus, and its tail, Serpens cauda, is on the other. The Greeks identified Ophiuchus with Asclepius, the god of healing. I hope that's how you say that too. Because snakes were one of his symbols. A triangle of stars forming the serpent's head is easy to recognize. The famous Eagle Nebula lies in Serpens cauda. I like that one. Let's look at the southern hemisphere. Let's turn this very crinkly, squeaky book around so we can look at the other side of the world. There we go. Alright, in the southern hemisphere, the Milky Way is directly overhead this month, making it easily visible on clear, dark nights. How special. The well-known constellations of Scorpius and Sagittarius dominate the night sky, but Triangulum Austral, Norma, and Ara are also nearby in the Milky Way. Never heard of those before. Hope it's Austral. Anyway, although there are no very bright, deep sky objects in these constellations, they are worth scanning with binoculars, as attractive star clusters are scattered throughout this area of the sky. So let's see. Nearby in the Milky Way. So let's see, it'll be opposite. So there's Scorpius. And so I see Ara, Norma, Triangulum Austral. Yep, they were right nearby. And then Sagittarius is over here now. Triangulum Austral. Let's learn more about it. It's like a really good triangle shape, isn't it? Better than Northern Hemisphere Triangulum, probably. Anyway, like many southern constellations, Triangulum Austral was introduced in the 16th century when star patterns invisible from the north were named for the first time. Triangulum Austral means the southern triangle, and it is often pictured as a carpenter's tool. Its three bright corner stars form a distinctive pattern that can be spotted easily in the Milky Way. And then there's Norma and Ara, which again is how I hope that's pronounced, but anyway. Norma and Ara lie side by side in the Milky Way. Norma depicts another carpenter's tool, a set square or a level. Gamma Normae consists of two yellow stars, both visible to the naked eye. But this is not a double star, just two stars at different distances, near in the sky by chance. Ara the altar contains several luminous giant stars, visible to the naked eye, even though they are very distant. Cool. It says, did you know? The ancient Greeks saw the constellation of Ara as a heavenly altar at which their gods pledged an allegiance to one another before the battle with their enemies, the Titans. The two stars that were once named Alpha and Beta in Norma are now allocated to neighboring Scorpius. The brightest star left in Norma is Gamma. It's that close, Norma. Oh yeah. Anyway, let's turn this and let's read a little bit more about Scorpius, the scorpion. There we go. Scorpius. Anyway, Scorpius. Constellation of Scorpius, the Scorpion, lies between Libra and Sagittarius in the Milky Way. It is not hard to imagine this pattern of stars resembling a scorpion with its claws and stinging tail. Yeah, this is always one of my favorites because it's really easy to find. Anyway, an arc of stars marks the curve of its raised tail, and the fiery red star Antares lies at its heart. In Greek mythology, the hunter Orion was killed by the sting of the scorpion. Scorpius rises in the sky as Orion sets, which means the two enemies are now kept apart. At one time, the scorpion figure included the stars of Libra, making it the largest of all star groups. Scorpius contains a number of eye-catching clusters, some visible to the naked eye. Let's take a look on this page so you can see. Can you see the bottom? No. There we go. I guess that's for the best. You can see the whole constellation. This big part, and then it goes pew, like that. Makes the tail. And there's Antares, the alpha star. So when you take this off, it's a little hard to see with all the extra stars, but when you live in a place like I do, you can only see the bright stars, and you can see this clearly, and the big hook, and you can see this part. It's very easy to spot, especially when the sky's so red sometimes. It's such a pretty star. Let's see. Let's read about some of the things on here. We have open clusters M6 and M7, which you can see are right here and here, right by the tail. Although they appear to be close together in the sky, these two open clusters are really far apart. Let's see. M6, which looks smaller, is 2,000 light years away. M7, the more southerly, is only about 780 light years away. M6 is visible with the naked eye, but its individual stars are best seen with binoculars. Both clusters are hard to see from northerly latitudes. You've never noticed those. M6, M7. Let's see what this is. Scorpius X1. In Scorpius lies a brilliant source of X-rays, the brightest in the whole sky aside from the sun. However, through a telescope only a faint bluish star is visible. This is actually a pair of stars, one of which is a collapsed star, probably a neutron star. When gas from the other star falls onto it, there is a great flare of X-rays. So let's see. Right here we have a blue star orbiting the neutron star, releasing gas. A stream of gas is drawn toward the companion neutron star. The extreme heating creates X-rays when gas hits the accretion disk. It says a disk of hot gas, known as an accretion disk, surrounds the neutron star. Then coming out are X-rays. X-rays are also produced when hot gas falls onto the neutron star. Wow. That's pretty cool, although apparently with a telescope you can only see this part. It's kind of a bummer. That'd be cool to see all of this. Anyway, let's read about Antares. Antares, which there's a little picture of him right there. Let's go like that so you can see. Antares. You can see him right there. Antares is the brightest star in Scorpius and the 13th brightest in the sky. It gets its name from the planet Mars. Antares means the rival of Mars in Greek. When Mars is close to the star, as it is every couple of years or so, you can see why. The two are very similar in color and brightness. Antares has a blue-white companion star, visible with a telescope. Interesting. Then it says, did you know? Did you know? There we go. Antares is slowly evaporating due to a fierce wind that blows from its surface, encasing it in a small gas cloud or nebula. This cloud is only visible because of the glow emitted by a nearby hot companion star. Oh, I don't want Antares to evaporate. Oh well. The Polynesians, there we go, Polynesians did not see the constellation of Scorpius as a scorpion, but saw it as a simple fishhook, which makes a lot of sense. Right. Let's listen to these sounds for a minute. Ooh. There we go. Alright, we're playing. Let's learn about the sun. The sun. The nearest star to Earth is the sun. It lies at the center of the solar system, and its mighty gravity keeps the planets in orbit around it. Even at 109 times the diameter of Earth, the sun is just an average-sized star. Like all stars, it is an enormous ball of hot gas, with nuclear reactions in its center giving it the energy to shine. In fact, without its heat and light, life on Earth could not exist. The sun is so bright that it will blind anyone who looks at it directly, so astronomers use special instruments to study it safely. They have found that the sun's surface is a yellowish shade of white, and it often has dark patches called sunspots. Let's see the Earth's seasons. So, Earth's axis is tilted so that its north and south hemispheres lean toward and away from the sun at different times during our planet's year-long orbit. This is the reason for the seasons. When a hemisphere is leaning toward the sun, for example, it receives more light, days are longer, and it is summer. So here we can see Earth's axis tilted at 23.5 degrees. And this is a picture you can see of Africa right there. So the sun is pointing at this part, but it's equidistant. So this is the equinox, fall and spring. We're facing this way. You can see Africa. So South Africa is facing the sun, but like Egypt and Libya, Algeria are facing away. So it's summer down here and winter up here in December. Then we rotate this way, another equinox, nice even sunlight and night. And then when it moves this way in June, you can see Northern Africa's right here, South Africa's right here. So now it's summer up here in June and winter down here in June. That's why we have seasons. Sorry for that loud siren outside. Let's see, I'll list eclipses until 2010. That tells you how old this book is. Let's read about solar eclipses, which if you haven't seen one, I got to see the one in 2017. It was literally life-changing. It was so beautiful. Literally looked like this. Solar eclipses. Can you see? At a weird angle. There we go. From time to time, the moon passes directly in front of the sun and casts a shadow over the earth. Anyone exactly within this shadow will see the sun blotted out by the moon for a few minutes. This is known as a total solar eclipse. To view this special eclipse, glasses must be worn to avoid eye damage. Just before or after the total eclipse, the sun may briefly shine through a valley of the moon, giving what is called a diamond ring effect. You can see that right here. So pretty. And my friends and I went up to Oregon to watch the total eclipse, and it was so unreal. It only lasted for about 4 minutes, but it wasn't like dark. Everything was just like this creepy purpley shade everywhere, and it got very cold, and the birds were kind of starting to sing but didn't know what to do, so they were singing some weird songs, and for a couple minutes I felt like I was on some other planet or that I was dreaming or something. It was so bizarre, but so beautiful at the same time. Oh my gosh, it was gorgeous. Anyway, enough about me. Let's learn about the sun. Sun from Soho. It says the spacecraft Soho, or the Solar and Heliospheric Observatory, monitors the sun's surface and takes photographs using different wavelengths of light. This ultraviolet image shows the light given off from helium gas at temperatures of about 110,000 degrees Fahrenheit or 60,000 degrees Celsius. The hottest areas appear white. Right there. Right there. Let's see. What else do we have? Auroras. This is something I want to see someday. Streams of solar particles can disturb Earth's magnetic field and send particles already trapped there shooting into the atmosphere. They collide with air molecules, which emit light. The resulting nighttime glows are called auroras. These usually occur near the poles. The northern lights are called aurora borealis. This is in Finland, apparently. And the southern lights, aurora australis. When the sun is violently active, auroras can be seen over a wider area. I feel like I'm definitely gonna see that sometime, just don't know where. Let's read about coronal mass ejection. Sounds scary. particles are constantly streaming off the sun, creating the solar wind, but sometimes a cloud of up to 1 billion tons of gas is blasted into space by a huge explosion on the sun's surface. This is known as a coronal mass ejection, or a CME. If one reaches Earth, it can wreak havoc on our planet's magnetic field, disrupting communications and power lines and causing dramatic auroras. Wow, so here we can see the pew pew. If you've seen the movie Knowing, which is a terrible, terrible movie, they talk about this happening. See, it says the sun's bright light is hidden behind a disk. This image from Soho. Interesting. And then the coronal mass ejection shoots out from an active region in the sun. Wow. And then let's read about sunspots. There we go. It says, dark patches on the sun's surface are called sunspots. These spots are about 2,700 degrees Fahrenheit or 1,500 degrees Celsius cooler than the rest of the surface. They are caused by flowing gas inside the sun, creating magnetism that restricts light and heat from certain parts of the surface. The overall number of sunspots varies, rising to a maximum and decreasing again over an 11-year cycle. Sunspots. Doesn't this kind of look like Van Gogh's sunflowers in a way? That's what it reminds me of. Solar telescope image of sunspot. And that's it for tonight. Here we go. So let me just make some more page sounds with this wonderful binding. Ooh, that one was a little loud. I think I'm at the point, I'm at like the midpoint in the book, so it's like evenly lumpy. Why are my cat's hairs everywhere? I swear. There we go. Thank you so much for watching. I hope you found this video relaxing and educational. And I hope that you have a very good